Okay, today we're going to be talking about three-dimensional figures. And there are two main types of figures, and that is prisms and pyramids. Okay, now there are a lot of different types of each of these. Okay, but these are the two main categories. Alright, so a prism. A prism is something that has two bases. Okay, now we're going to talk more about what bases mean in a minute, but this basically means that both ends of the shape are the same. Okay, this is an example of a prism. Okay, the front and the back are the same, or in this case the bottom and the top are the same. They're the exact same shape. They're congruent. Okay, now that shape could be a triangle, a rectangle, an octagon, it doesn't matter, but it has to be a polynomial. Okay, so a prism is anything that has congruent polynomials on opposite sides. Okay, so this rectangle in the front and this rectangle in the back are congruent, so that makes this a prism. Okay, so it's kind of like a pipe, if you will, but it's a pipe that might be shaped like a square, or a pipe that might be shaped like a trapezoid, or any polygon. So, the front of this pipe is a rectangle, so the back of that pipe is a rectangle. Okay, and that's what a prism is. Now, a pyramid. A pyramid only has one base. Okay, so on one side you have a polygon, and on the other side it comes to a point. Okay, now it's just like a pyramid that you think of when you think of like Egypt. Okay, you can see there is a polygon on the bottom, and the top comes to a point. So this only has one base. Okay, again, up here you have sides that are opposite sides that are parallel to each other that are congruent. Down here you don't have that, because where the other rectangle would be, instead of having another rectangle up here, it all just came to a point and there's nothing. Okay, that's what makes this a pyramid, is it only has one base. The main difference between a prism and a pyramid is a prism has two bases, has a top and a bottom, and a pyramid only has one. It only has a bottom. There is no top. Okay, so now we're going to look at these a little more in depth. We're going to look at the characteristics of each and be able to label them. Now, you guys looked these up the other day. Okay, so we're going to go over them, and this should be something that's somewhat familiar. Okay, so first we're going to talk about a rectangular prism. Okay, now, and we're going to talk about a triangular prism. Now, a rectangular prism, what that means is that the bases are rectangles. So it's a prism made out of a rectangle. So in other words, it's like the pipe again, except for the pipe is shaped like a rectangle. So the front is a rectangle and the back is a rectangle. Okay? And a triangular prism is the same idea, except for it's made from a triangle. So the front is a triangle and the back is a triangle. You can see it's like a pipe, except for it's shaped like a triangle. Okay, so now you notice, what shape are the sides? Well, for the triangular prism, the sides are rectangles. And for the rectangular prism, the sides are rectangles. Okay, that's the case for any prism. Okay, the sides that aren't the bases are always rectangles. Okay, so that's what makes the rectangular prism a little bit more confusing, is it's not quite so easy to see which sides are the bases, because they're all rectangles, so any of them could be the bases. It's pretty easy to tell on this one that obviously it's the triangle going to the other triangle, because those are the only ones that are parallel. Okay, so, but you can see that the name is what tells you the shape of the base. Okay, so like I said, we could have other types of bases as well. Okay, you could have one with the trapezoid base, or a hexagon base, or anything. Really, you can have an irregular shape for a base as well. It would just be very awkward, I guess. Okay, but you can have any polygon at the base of a prism. Alright, so now let's look a little more in depth at our rectangular prism. Our pyramids. Okay, because we also have rectangular pyramids and triangular pyramids. Okay, and they mean exactly what you think. Again, a rectangular pyramid means that the base of the pyramid is a rectangle, which, by the way, could be a square as well. Okay, and a triangular pyramid means that the base of the pyramid is a triangle. Now, sometimes these figures get kind of hard to see because some of the lines are actually behind other lines and things like that. So notice what I'm going to do. I'm going to make some of these lines dotted. Okay? Now, if you see a dotted line, what that means is that these lines are actually in the back of the shape. You can't actually see them. Like if you were looking at this solid figure, you wouldn't see that line. Okay? You would only see the front sides. But the dotted line lets you know that that's where the line is on the other side if you could see it. Okay, that sometimes helps you kind of visualize what the shape actually looks like. Alright, and like I said again, the name tells you what the shape of the base is. Okay, so the shape of the base, since this says rectangular pyramid, then the bottom is a rectangle. And since this one says triangular base, that the base of this one is a triangle. Alright, now, earlier y'all looked up different things about these different shapes. Okay, and we call those things characteristics. So we're going to look at the characteristics of these different shapes. Okay, these words should be familiar. You tried to look them up online the other day. Okay, so we have bases, faces, edges, and vertices. Okay, you will need to know how many bases, faces, edges, and vertices that each of our figures have. Okay, or you would need to be able to find them more specifically. Okay, so we need to know what they are. Well, a base, we've kind of already used that word today. Okay, a base is the special face or faces that build the figure. Okay, so like I was saying, a triangular prism is really built from a triangle. Okay, so that's why the bases are triangles. Okay, so it's the sides that are a little bit more important because they actually are different depending on the different prism or the different pyramid. Okay, that'll make a little more sense when we start identifying the bases on the actual shape. Okay, but it's kind of how you built the pyramid. A triangular pyramid is built from the triangle on the bottom. Okay, a rectangular prism is built from the rectangles across the prism. All right, faces. Okay, faces are just the sides of the figure. That's it. Okay, it's just how many sides does the figure have. Okay, so that's what this means up here, the special sides. Okay, so your bases are actually faces as well. They're just the special faces. Okay, now edges. Edges occur where two faces meet. So if you think about your shape, okay, anywhere there's two faces touching, that's where you get an edge. Now, how can you find that when you're looking at a shape? Well, it's pretty simple. It's just, that's the lines. Okay, the lines you draw when you're drawing the prism or the pyramid, those are the edges. Okay, think about your prism. The spot where two faces meet, it kind of falls off like a cliff. Well, that's because it's like an edge, the edge of a cliff. Okay, that's why we call it an edge. Okay, it's where the shape or the figure actually turns. It has an edge there. Okay, like a cliff. And then vertices, those happen where two or more edges meet. Okay, so if you're thinking of your prism again, then what happens where the edges come together? Well, you get a corner. Okay, so the vertices are just the corners. All right, so if you look at this, really we have faces, edges, and vertices because bases are just special faces to identify. Okay, so faces are just the sides, and then the edges are where the sides touch, and then the vertices are where the edges touch. Okay, so we're going to have to be able to count how much of all of these each figure has. Okay, so we may be coming back to this if we need to, or referring back to this throughout the rest of the video. All right, so first let's look at a rectangular prism. I'm going to go through this one with you, and then I'm going to see if you can do some of the other ones by yourself, and we'll check them. So all we're going to do here is try to count how many bases, how many faces, how many edges, and how many vertices that this rectangular prism has. Okay? Now, if I go back to this first slide, what do you notice that I said about prisms? They all have two bases. So all prisms have two bases. So I already know that since this is a prism, it's going to have two bases. But again, think about this. We need to know where they are. Okay? So if this was a pipe, kind of you can picture water flowing through here like it was a gutter, then the bases would be this front piece and this back piece. So those are my two bases. Remember, the bases have to be parallel to each other, and they have to be congruent. So they have to be exactly the same shape. Okay, and these two are. All right, now faces. Now, this might get a little messy as I start shading this one in. Okay, but I'm trying to see how many sides there are. Well, first, the two bases are already faces, so I know I'm starting out with 2. Well, then I can color the top, that's 3. That back side, that's 4. The bottom, that's 5. And this front piece, that's 6. So there are 6 faces on a rectangular prism. Okay, now the edges. That's where 2 faces touch. So where the top right here touches this side, that makes the edge. Oh yeah, didn't we say those were the lines? So really all I have to do is see how many lines did it take to make this shape. Because think about it, if you were on top of this box and you walked, wouldn't that line be the edge of the cliff before you fell off the side? Okay, that's why it's an edge. Okay, so I have 1, 2, 3, 4 edges on the back side. I have 1, 2, 3, 4 edges on the front side, and then I have 1, 2, 3, 4 edges going around. So that's 4, 4, and 4, so I have 12 edges. Alright, and then for vertices, that's where the edges touch. Like this spot right here. Here's 3 edges all coming together, so that must be a vertex. One of my vertices. Okay, well look what happens where they touch. You get a corner. So all you have to do is count the corners. Okay, so there's a corner. I'm going to put red dots on all the corners. Alright, that's all my corners. So that must mean I have 8 corners. So I have 8 vertices. Okay, so this is how many bases, faces, edges, and vertices. And once you know this for one rectangular prism, you know it for all, because all rectangular prisms have the same amount of bases, faces, edges, and vertices. Okay, so you could either memorize it, or if you understand how to do it, it doesn't take you that long to count each time. Either way is fine, but you will have to be able to identify the number of each of these for a rectangular prism. Alright, so now we're going to look at the same stuff, but this time for a triangular prism. So again, a triangular prism is made up of 2 bases that are triangles. Okay, so you have one end of the prism down here, or one base, and the other base or the prism back there. Okay, so this time I want you to try to write down how many bases, faces, edges, and vertices that are in this triangular prism, and then we'll see if you got it right. Alright, so first notice that I just put BFEV. That's bases, faces, edges, vertices. Okay, just so we don't have to keep writing out the words over and over again. Okay, again, the bases, well, all prisms have 2 bases. So just by knowing it's a prism, I know it has 2 bases. But how do I know it's a prism? Well, I look and I see, are there 2 parallel sides that are congruent? Yes, these 2 triangles are the same shape and they're parallel to each other. Okay, so that means I have 2 bases. Okay, now for the faces, I have both bases, so that's already 2 faces. Then I have this back side, that's 3, the bottom, that's 4, and then this front, the top part right here, that's 5. So there are 5 faces on a triangular prism. Then the edges, again, are the lines where all the faces meet. So I've got 1, 2, 3 on this front piece, and then I've got 1, 2, 3 on the back side, and then 1, 2, 3 going around. So that's 3, 3, and 3. So I've got 9 edges. Okay, and then the vertices, all the corners. So there's 1, 2, 3, 4, 5, 6. That's all the corners we have on this prism. So a triangular prism has 6 vertices. Okay? So this is all the characteristics for every triangular prism. Okay, notice it's not the same as a rectangular prism. The only thing that's the same is the bases, because all prisms have 2 bases. Okay, but they have different number of faces, edges, and vertices because those shapes on the end are different shapes. So they have a different number of sides and different number of angles and things like that. So that makes the faces, edges, and vertices different every time. All right. Now, let's look at the pyramids. We're going to look at a rectangular pyramid and a triangular pyramid. Okay, rectangular pyramid just means it has a pyramid on the bottom, a polygon on the bottom, and it comes up to a point on the top. Okay. Well, for a rectangular, it means that polygon is a rectangle. And then for a triangular, it means that polygon is a triangle. There's my triangle on the bottom, and then I have the point on the top. Now again, I'm going to make some of these lines dotted that are in the back so that you can tell that that's the back side. So you can't actually see that if it was solid, but if it was, say glass, you would be able to see it. Okay? So now you're going to list the number of bases, faces, edges, and vertices for each of these pyramids. And then we'll see if we can look at them together. Alright, so remember, prisms have 2 bases. That's what makes something a prism. But what makes something a pyramid is that it only has 1 base. Okay? There's nothing else on the opposite side that's the same shape. It comes to a point, so there's no shape over there. So this only has 1 base. Okay? And now the faces. Well, the bottom is the base is 1 face. So then I have on the triangular pyramid, I also have 1 base. Okay? And then looking back at the rectangular pyramid, I'm looking for the faces. So I've got the 2 sides on the top. That's 1, 2, and the base is on the bottom. That's 3. And then the back side, that's 4, and then the front side. So that's 5 faces. And then for the triangular pyramid, again the base is 1 face, and then that back side is another face, and the side kind of on the front is a 3rd face, and over on the right is a 4th face. So there are 4 faces on a triangular pyramid. The bottom, and then the 3 sides around. Okay, and now for the edges, the rectangular pyramid, there's 4 edges around the bottom, around the rectangle, and then 4 edges going up to the point. So that's a total of 8 edges on a rectangular pyramid. For the triangular, there's 3 around the bottom, and then 3 going up to the point, so that's 6. And then for the vertices, you have 4 around the bottom and the 1 point on top. So that's 5 vertices for a rectangular pyramid, and for the triangular, 3 around the bottom and 1 on the top. So that's 4. Okay, so those are our characteristics for rectangular pyramids and triangular pyramids. And that's all rectangular pyramids and all triangular pyramids. Okay, so now we're going to talk about something, or 2 things, that don't technically fit into the prism and pyramid category, but they kind of do. Okay? They fit with them in all but name, really. Okay? And that's cylinders and cones. Okay? Now, remember when we defined a prism, or when I mentioned it earlier, I said that the bases, it had two bases, and that the bases had to be polygons. Well, we all know a shape that's not a polygon, and that's a circle. Okay, so a cylinder is basically just a prism, except the bases are circles. So since circles aren't polygons, we can't call it a prism. So we have another name for it, and it's a cylinder. Okay, and then a cone is basically a pyramid, except for the base of a pyramid, again, has to be a polygon, and circles aren't polygons. Okay, so we have cylinders and cones as well, which, like I said, basically are prisms and pyramids. It's just that they have circles for their bases. Okay, so we're going to find the number of bases, faces, edges, and vertices for each of these as well. Alright, so for a cylinder, again, since it's like a prism, yes, it has the bottom and the top, so it has two bases. Now, if you picture this, or think about those of you that chose to make the cylinder, when we're looking at faces, the top and the bottom, the two bases are faces. But what was this other piece that was wrapped around? Okay, if you unfolded it, it really just made a rectangle. So that's one more face. So that makes three faces for a cylinder. Okay, now the edges on this one can be a little tricky as well. Okay, the top side is an edge, because if you were standing on top of it and walked off, you'd fall off the edge of a cliff, right? Okay, so the circle on the top is an edge, and that also means that the circle on the bottom, because if I flipped it over, that would be the same thing. So I have those two edges, and those are lines, so that makes sense. But what about these lines on the side? Are they edges? Because we said lines were edges. But if you think about an actual cylinder, is there a line there? Okay, there's not, right? It just kind of curves around. The line is really just what we see. That's how we draw it, because we can't draw it perfectly. But it really just curves around. There's no actual edge. If you were standing on the side of this and walking around, you would never fall off. Okay, there's no edge of a cliff when you walk around that way. So the lines on the side are not edges. Okay, so a cylinder only has two edges, the top rim and the bottom rim. And then vertices. Okay, first, there's nowhere that edges meet. That's why we get no corners. And if there's no corners, that's why we have 0 vertices. Okay, the cylinder does not have a vertex because it does not have any point where edges meet. Okay, and it has no corners. All right, now a cone. Since a cone is like a pyramid, yep, it has one base that's on the bottom. Okay, and then again the faces, the bottom is a face, the base is a face, and then this shape on the top, when you unfolded it, it kind of made almost kind of like a circle. Okay, a little bit like a half circle almost. So it is a face as well. So we have two faces on a cone. Okay, and then again the edges can be tricky, just like the cylinders were. Okay, the bottom circle is definitely an edge, because if you held it up like an ice cream cone and walked off the side, it drops off like a cliff. Okay, but these lines are not edges, because again, you could just walk all the way around them if it was on its side, and you'd never run off of a cliff. Okay, so there is only one edge on a cone, and it's that bottom circle. Alright, now, the vertex. This one can be tricky for a cone. And the reason being is you could actually argue two ways. First, the first definition of a vertex says that it's where two or more edges meet. Well, this shape only has one edge. So obviously there's no place on it where two or more edges meet. So there must be 0 vertices. Okay? But the other definition says it's a corner. And I'm pretty sure I see a corner right here. So is this point a vertex or not? Because it meets one definition of a vertex, but it doesn't meet the other. Well, this is one of those things in math where it depends on who you ask. So you can give either answer, 0 or 1, and I will accept it as long as you can explain your answer. Okay, if you say it's 0, then it's because there are no edges meeting right here. So you're saying, nope, it's not a vertex because no edges touch. And if you say 1, then you can say, yes, this one is a vertex because it's a corner. So it's a vertex. All right, so that's our bases, faces, edges, and vertices for cylinders and cones. All right, and last, this one doesn't fit into any category. Okay, it is a sphere. Okay, a sphere is basically a 3D circle. Okay, so this one doesn't fit. It's not like a prism. It's not like a pyramid. It's not like a cylinder or a cone. Okay, it's in the category all by itself. Okay, it's a sphere. So we're going to find the bases, faces, edges, and vertices. Okay, now first, there are no bases for a sphere. Okay, there's no place for it to sit. It just rolls around. Okay, so there's no bottom and top. There's no congruent sides. There's no polygon on here at all. Okay, there's really no shape on here at all because the surface is all curved. All right, so there are no bases. All right, well, what about faces? Okay, well, there's no bases, so that doesn't count as a face. But, all right, I could still unfold this, and all the way around would give me one face. So this sphere is just one face all wrapped up into a ball. All right, now, if an edge is where two faces meet, and I only have one face, then I must not have anywhere that two of them meet, so I have no edges. Okay, and again, we said edges were like the lines, but are these lines actually there? Are these lines on the sphere? No, they're just the formation of the sphere. There's not actually a line there. It just curves around to the other side. So there's nowhere you would drop off of this sphere. You could walk all over it all day long, as long as you had good enough balance. All right, now, so what about vertices? Well, if I don't have any edges, then how can two or more edges meet? So I must have 0 vertices. Okay, and there's no corners on a sphere. It's all round. It's all flat. So there's no corners, so there's 0 vertices on a sphere. Okay, all right, so looking through this, this is basically what you're going to have to be able to do after today's lesson, is name these figures and identify how many bases, faces, edges, and vertices. So you should be able to name, you should be able to look at the figure and know that it's a rectangular prism and know how many bases, faces, edges, and vertices. Do the same with triangular prisms and both types of pyramids, cylinders and cones, and spheres. Now, and I will also mention this. These aren't the only types of prisms because the bases don't have to be rectangles or triangles. Like I said before, they could be octagons. Okay, they could be anything. You still need to know that that's a prism. and you can still find the number of bases, faces, edges, and vertices. Okay? So it's a pretty simple lesson, but it's a lot of pieces to remember. Okay? A lot of things to find. So just make sure you can identify the figure and name or label the characteristics.